hope you had a nice lunch break and everyone is kind of ready to spend 45 minutes listening to me rambling on about error handling and crash reporting. Yay! Woohoo! All right, so for the people who don't know me, my name is Kai. I'm that guy who moved from Germany to New Zealand, and I do a lot of work in the backend and mobile app space, essentially. And most of my tech that I use is CFML or other JVM languages, some Python and Ruby stuff, and doing a lot of stuff with Unix and Linux infrastructure platforms. On the front-end side, I'm not a web developer. I have to readily admit that. I hate JavaScript and building websites. I love building native apps, though. That is really cool, and APIs, but like, I could spend another 2 hours talking about why I hate JavaScript frameworks. So let's not go down that path. So why did I want to give this talk? Essentially, because errors and crashes happen all the time, unfortunately. And you will see a few more of these XKCD comics during this presentation, right? What we're going to do is we look at crash and error handling mainly from a backend dev point of view here. However, a lot of stuff is also relevant for front-end development. And a lot of these crash reporting techniques or crash reporting services exist for both backend and front-end technology, right? And when you think about it, in front-end land, it's even more important, right? If you have native apps out with your clients, and the app crashes on a user's phone, I mean, you don't really know about that, right? On a backend platform, at least, you have your server logs, hopefully. Or you do whatever you do to keep track of errors in some way, but you have control over this data. In front-end land, both web clients and native clients, you don't have that direct control. So we said already that errors actually do happen. And in general, it's very unlikely, and I would say impossible, that your software is bug-free. I mean, even like organizations like the NASA or something like that, they don't have bug-free software, as we sadly know. And the other problem that we face with dealing with errors and crashes is that users' bug reports are regularly not super helpful. You get stuff like, it doesn't work. It worked yesterday in Firefox, so I don't know what's wrong now, broken. Or fix your stuff, or I cancel my subscription. One of those people who pay like $5 a month for your service are usually, or often, the people who complain the loudest. So you get this kind of stuff, and you don't necessarily get good bug reports. At the same time, we have a quite high cost of errors, right? So users don't like to report bugs. How many bugs actually happen that are not reported? Think about that. Think about that hidden layer of stuff that happens behind the scenes that you don't even know about. And what is the impact of that on user experience, and how many customers and users do you lose for your business? Because there is some bug that you have no idea that it actually happens in the first place. So it's usually a very much tip of the iceberg scenario. If you hear about an issue happening from a customer or from your customer service people, for example, it's usually happening quite big time behind the scenes already. So let's have a look at some terminology. And the first thing is, there is a difference between logging and, I told you there are many of these XKCD comics around crashes and errors and stuff like that. So there is a difference between logging and crash reporting. And that's an important distinction to make, actually. So logging is usually something where you write information as a line item into a file. Think about, I don't know, application log in Cold Fusion or Lucy or something like that. Or think about you run a Linux or Mac system and you have like syslog or messages.log in your var logs directory. And even in Windows land, you have sort of an event log that is typically presented as a UI where you have to click through, but I would assume, even though I don't know, that there is some sort of a text file or a data store behind that, right? So that's logging. And quite often you have mechanisms like it rotates over a size or a time frame. So If your log file becomes 10 meg large, it creates a new one, continues to log into the new file, your old file gets zipped up, and it keeps like, I don't know, 10 instances of the old file, something like that. Crash reporting, however, is different. Crash reporting is, from my point of view, storing detailed and also structured information somewhere, right? And the big difference is structured and somewhere, and that somewhere is quite often not a text file, but some other place that is better suited for structured information. So here we've got a typical example of logging. That's kind of a Lucy log directory, if I recall that directory correctly, what I took here, that screenshot. And crash reporting gives you kind of more. It gives you a system of analysis of where your crashes happen, what happens, what data was collected along the way. And one of these, results of a crash reporting system might be a graph that shows you like, hey, there is a spike of things happening at 6 p.m. every day. I wonder what that is, right? So something is happening there, apparently. And at the same time, it's all the shades of gray in some way, right? There's not a hard boundary between logging and crash reporting. And also, not every solution fits nicely into either logging or crash reporting. So for example, think about like something that probably everyone has done at some point, right? Like you send emails to yourself, like you do a CF dump form and do a CF mail around it, and it's like, hey, I'm reporting my crashes to myself or some information or something like that. Or you have an error handler file, and the only thing you do is you dump a bunch of scopes and send them to yourself, right? So is that crash reporting? Is it logging? Is it just bad practice? I mean, could be many things, essentially. Other typical scenarios you find is logging to your SQL database. I would personally argue that's much better than sending emails to individual developers. However, a SQL database is not necessarily the best place to store that information either. Or you have log files written to disk, right? So what we see here is a typical scenario what people would store in a database, right? You might have something like an error ID, a member ID, maybe the template URL or the template file name your error was happening, and you just dump it into a database table, flat structure, quite nicely, denormalized, and then what? I mean, what do you do with that data after there? It sits in a table, cool. That table grows over time, and depending on how many problems you're logging, you end up having, I don't know, a few million records after a year or something like that. But, you need to do something with this information. And that's why traditional error tracking, using email, database tables, and similar mechanisms is kind of problematic. So the email thing, it's for a start information overload. So you end up getting hundreds of emails. They might run into spam filters, they might run into Gmail filters. And at some point, if you get all these emails, you stop looking at them. I can guarantee you that, right? It's kind of a human nature. At some point, the first step is like, I filter them into this Gmail label. And I will look at the Gmail label every morning. And after a week, you just ignore that Gmail label. That's kind of what happens, basically. Logging to a SQL database, I'm of the firm opinion that not everything that can be stored in a SQL database should be stored in a SQL database. A lot of folks in dev communities see kind of SQL as the solution to every problem for storage, right? And that's quite unfortunate because quite often there are better ways to store information. Like even think about Redis or think about Couchbase or something like that, where we can store structured data that doesn't necessarily have a particular schema in a very nice and very scalable way that is much better than a database table. Also, like I said earlier, if you just dump data into a table, at some point the interest in checking the table will fade away. So you have to build your own kind of reporting system around that table anyway, because otherwise the whole thing becomes totally pointless. Log files written to disk has a similar problem like emails, information overload. You end up with these massive files. There's no structure but a time series order. And if you have multiple servers across a cluster, I mean, you need some log collector service, or otherwise you log into 10 servers every morning and check log files, and that's, again, not going to happen after the first week, realistically, human nature. All right, so we've seen that there are some problems around error handling and crash reporting. Let's go back to basics and let's have a look like how CFML platforms actually deal with issues in the first place. And the common terminology that we come across quite often is like there are errors and there are exceptions. In different technologies, these terms are used differently. And that's one thing that is really important to realize. Just because these terms exist doesn't mean that every platform uses both of them or use them for the same meaning, right? So quite often used interchangeably. So there are technologies or there are people who talk about errors when they really mean exceptions, and they talk about exceptions when they really mean something has happened on their server, but they don't really know exactly what. There are conceptual differences, and there are, I think, two very generic ways to describe them. An error is essentially a problem or a fault or something that goes wrong, right? And I'll show you a very practical example in a minute. An exception is, in general, a class of an error that is somehow expected or known to occur and being dealt with. So, for example, in Java land, these definitions for error and exception kind of work, but Java has additionally checked and unchecked exceptions. And what it comes down to pretty much in that case is like checked exceptions are things that the compiler will check while it's compiling the Java code to bytecode. So for example, a function that, I don't know, throws an exception and you don't handle that function while you're calling it, that will be a checked exception because it triggers at compile time. Unchecked exceptions in Java are things like division by 0, right? That happen at runtime, and you don't really know at compile time these things happen. And we'll see in a minute that in Cold Fusion or Lucy land, these kind of differences blur into a blob of something, whatever exactly that is. So let's have a look at an example of error versus exception. So here we have a dishwasher, right? So someone used the wrong dishwashing liquid or soap for this dishwasher. What happened is it kind of spilled. Clearly a user error because that person didn't read the manual, right? So we have an error here. Here we have another dishwasher that is showing E25 on a Bosch or Siemens or whatever machine, basically. That is essentially for water not emptying, so it doesn't drain properly. That is an error that was handled nicely by the engineers of this dishwasher by throwing an exception E25, which, you know, as a normal person, you would probably describe as an error code, which it kind of is, but it really, in technical terms, this is an exception, right? So the water didn't spill because someone stopped that from happening by saying like, hey, I'm full of water, something is not right here, don't put more water into my drainage system, essentially. In CFML, when we look at some concepts, when both ACF or Lucy encounter issues, they create kind of errors or exceptions. In CFML, because of the way how the servers work, runtime and compile time kind of mesh into each other. It's really hard to make a clear distinction compared to, for example, how Java works, where you can say something happens at compile time, something happens at runtime. There are different error types and exception types. So there's a database error, missing include error, template error, whatever exactly that means, it's actually very wide. Object errors, expression errors, and then there is the magic type any that just fits everything else, essentially, right? when you look at like where things happen, I almost feel like closest to compile time errors in other languages are usually syntactical problems in CFML. So, I don't know, you're missing a curly brace somewhere, you run the page for the first time, or your template for the first time, and it basically says like, can't do that, right? That's the closest to a compile time error, even though, depending on your server platform that you're using, that might technically be even still happening at runtime. So there's no 100% matching to that. But quite often, these syntactical problems that are the closest to compile time errors happen or manifest as template errors. So here's an example of a variable not being defined. So it's doing some calculation, and then it runs into a variable C that is not there. That happens at what we would normally call at runtime. Here's another issue, also in Lucy, where I'm missing somewhere a curly brace. And what you can see is that is a template exception, and it says something like invalid syntax for closure, because something is not completed, right? So that second one is probably the closest that we know that we have to a compiler type error. So if you want to handle these errors or do something against these yellow screens popping up for your users, you need to handle them. And if you don't do anything, you see exactly these yellow pages, or like, I think blue pages these days in Adobe ColdFusion. And the detailed look and feel depends on how you've configured your CFML server and which one you're using in the first place. The last line of defense, if you don't do anything else, would usually be you set up a global error handler in your ColdFusion admin or your Lucy admin, or you use the cferror tag somewhere, and you say, this is my error handling template. Please run that if nothing else has stopped this from getting up so far in the call stack that it's about to be presented to the user. If you want to be a bit closer to your code, what you would usually do is use onError in your application CFC. That's at least kind of like fitting into a modern way of developing as kind of a global error handler, but it doesn't use like something you have to set up in your administrator. And what is usually closest to your code is try-catch. So basically wrapping a try-catch structure around a block of code, and you deal with whatever the problem is in an appropriate way for that piece of code. And that is independent advice or independent approaches regardless of what framework you use, right? It doesn't matter if you use Framework 1 or Fusebox or Codebox or God knows what else. You can use any of these techniques if you like to do that. Let's have a look at this one here. So we have a bit of CS script code, and we do a division A by B and then A by C. A by B obviously works, A by C doesn't work, and what we end up with is a message saying division by 0. That's obviously not possible. But what you notice in Lucy in this case, this is actually a Java stack trace, by the way, right? So we get a Lucy runtime EXP native exception. So this is kind of almost not a Lucy exception, because it stems from an underlying problem executing Java code. Like a division by 0 happens on the Java level in this case. If you want to prevent that, you can obviously set up, like I said before, a global error handler, and you can do the same thing in CFconfig, for example, with statements or lines in your JSON like general error template or missing error template, depending on what you want to catch. So if you now go ahead and wrap your code in a try-catch block, the stuff that is in try will be guarded and then trigger the execution of the catch block. But only if a matching exception type is being thrown. So if you don't match the exception type, it basically means it will bubble up to the next layer of your call stack. There is also a way to throw and rethrow your own exceptions at any stage, and I'll show you that in a second. So here we've got that same example with the division by 0, but now the difference is we are actually using try-catch around that, right? So instead of like just getting some sort of a Java Lucy error, I would expect that something else happens. And that else is defined by the catch statement. So we run into a problem and I say catch anything, whatever it is, and create an error object or an exception object E. And if we dump that, we don't get the yellow arrow page anymore, but we get something that looks like a struct, correct? So, I mean, this is kind of the Lucy design of what a struct looks like, but you will find similar in Adobe ColdFusion. And that error or exception object gives you information about like what the message was, if there was any other information, a stack trace, potentially a tag context that shows you where exactly in your CFML code the problem occurred. So that's cool. Now, if I remove the any and swap that against a Java lang arithmetic exception, I wonder what happens now. I could also use a Java lang number format issue. What would happen then? Let's go back to our stack trace and let's see what actually happens. And that's really hard. Huh? Yeah, here we go. Java lang arithmetic exception, right? So in my first example, when I go from any to actually catching this specific exception type, that will still work. If for whatever reason I come up with a random other exception, like catching Java lang number format issue, what will happen is the error is again bubbling up because it's not caught here, which means I will see the yellow arrow page again eventually. The interesting thing about error handling with try-catch is what, like the thing that looks like a struct that I was dumping on the screen before, it's actually not necessarily a struct. And that can catch you out quite a bit. So it looks like a CFML struct, but it is different. And unfortunately, it depends on the version of your server how this thing behaves. So in old versions of Adobe ColdFusion until, I think, ACF 11, it was actually behaving like a struct. So you could take that CFCatch exception object and you could modify it. So you could add a key to it or remove a key. With newer versions of ColdFusion and with Lucy, you can't do that. It's kind of its own exception, its own object. And that is really important to be aware of. So if I change that little bit of code with the division by 0 to dump the metadata of my exception object or an empty struct, and I look at the name of these different things, we'll find that we get a massive dump for a start. And I was like, oh my God, this is like big, right? And if you look closer into it, the exception object, I'll bring up the whole thing because then we can probably read it better. The exception object is of type Lucy runtime exp catch block impl. So it's the implementation of kind of a catch block interface. And the struct itself, like an empty struct, is of type Lucy runtime type struct impl. So that implements a struct interface on a Java level, right? And you can see, like, when you look at the dumps, all the different fields, the different constructors, it's a totally different object, essentially, right? So even though CFML presents it as a struct to us when we dump it, it looks blue like any other struct, it's really not. It's a completely different underlying implementation. And you find the same with Adobe ColdFusion. That's particularly interesting when you try to write a generic SDK for error handling, and all of a sudden, someone changes the underlying implementation, and all of a sudden, your code just explodes with a new version of Lucy, Adobe ColdFusion, or whatever you're using. Talking about frameworks. So I use CodeBox a lot, so I'll explain a few things around how error handling in ColdBox could be done. But obviously, people use other frameworks, so some of these general techniques might apply to other platforms, but some of them might not. So with ColdBox in general, you get a lot of additional features and conventions around error handling and exception handling if you want to. Usually it starts on a handler level. A handler in ColdBox is kind of a route coming into your system, and handler is, after some other framework stuff, the first place where your own code runs. And what I usually end up doing is I have my own handlers for my custom routes, and there are system handlers available as well, like a REST handler if you build an API, for example. So those are two options where you can do error and exception handling. You can also do it on a global level. So there are global handlers, there are global interceptors that basically jump into a request that comes in where you could do error handling. Or you could not do anything of that in a ColdBox application. You can just fall back to the CFML engine level error handling, right? I mean, no one forces you to use ColdBox error handling if you don't want to. You can just put a CF error somewhere. That's okay. I mean, not my preferred approach, but if you don't want to get into the details of like a framework level error handling, that's totally up to you. So what I usually do is when I build particularly API apps or API-based apps, all my application handlers extend a base handler. So I write a custom base handler for my project that itself inherits from a REST handler from the framework. And I use that base handler for my own code to externalize a whole bunch of things. And one of these things is, error handling. So I would basically put an onError function into my base handler and do whatever processing and tracking I want to do there, and explicitly not calling super onError. So I don't want the framework to be involved there. I just do that on my own. There is another function in ColdBox handlers called the onAnyOtherException handler. And in some instances, I use that for some additional logging. And then I pass it on to the inheritance chain from the framework, because the framework is doing some really useful things for some of these other exception handling bits. And my last line of defense is usually application CFCs on error. And I mainly use that if there's anything that I didn't really catch in the ColdBox application, or that kind of requires me to interject on a server engine level. So for example, if you want to get a Lucy timeout, or a Cold Fusion timeout even, right? So it's tricky to catch them in every single case in your own code. So you can do some trickery in the application CFC on error to make sure that you get them when the request times out, but then I want to get some extra time to log it somewhere, right? Because I want to log my timeout, for example. So you can extend the request timeout and do some probably semi-dodgy things that not always work as you would want to, but that's kind of the way to do these things. On top of that, I usually have like error templates set up that point to some CFML files. And the other thing not to forget is you probably want also error handling on the lowest level that you can have, which would be, in my case, what I do most of the time, command box undertow, or whatever other servlet engine you're using, like, I don't know, Tomcat or Jetty or something like that. And one way to do that in command box undertow is in your config file, there's a web section that has a subsection called error pages, where you can define error pages for pretty much any status code that you want to have caught on that servlet engine level. And what I do there is, as the super last line, low-level defense, I point it to HTML pages even, because I can't really guarantee that when an error happens on that low level that it can even execute CFML. Right? So that's more like to present something to the user that they don't get like a really bizarre low-level error. And with that, there is we've seen a whole bunch of ways to deal with errors. But we haven't really spoken about like how to, deal with them in a way that you can monitor them or look at them nicely. So there are a whole bunch of crash reporting tools and services. And they usually come as subscription services. You pay X dollars or euros a month to get so and so many things you can send to that service. The general benefits of these crash reporting or logging services are they give you a deep insight into frequency of your crashes and uniqueness of your crashes. And they have stuff like statistics and reporting, live dashboards, technology integrations, like, I don't know, you can collect errors from CFML, from Java, from your Flutter application, from your JavaScript code, feed them all into one system and see all sort of stuff. And usually they have ready-made integrations for third-party platforms. So let's say you want to be alerted from your crash reporting service into Slack or Microsoft Teams or via SMS. That stuff is usually possible. Alerting particularly is really interesting. And like, the more complex you can set up alerting chains, the more useful I find it. Stuff like, if this happens more than 5 times in a minute, then send an SMS to these people right away, because then basically, payment system is down or something like that. So typically, there are a bunch of services that people use often, like Raygun, Sentry, Airbrake. There are tons of others. And I'm not really going to say you should use one or the other. They are all reasonable from my point of view. I will show you some examples in Raygun in a few minutes, and that's mainly because I use that a lot. But that doesn't mean that Raygun is the only or the best system, or you should switch to Raygun. If you use Sentry and you're happy with that, that's perfectly fine, that's perfectly valid. What you want to check for is look at the features you need and make sure all your technology platforms that you deal with are supported and integrations are available. Because the biggest win from using a commercial crash reporting service, from my point of view, is the ability to correlate issues. Stuff like, I've got multiple charts and multiple graphs, and I can easily see visually that maybe that spike in the app has something to do with another smaller spike in the backend or something like that, right? So that you can actually compare different graphs and make kind of like, deduce what is going wrong and why things are going wrong. So Raygun is one of these services. And like I said, not saying like this is the best or the only thing you should use. I just use it a lot because I like it. So I'll show you some of the bits that work in there. There is a Raygun for CFML provider on ForgeBox that I have built years ago, and there is a new version coming out in a few weeks, basically. And it's simple to use, right? Like if you use something like ForgeBox or CodeBox dependencies, you just add a dependency, Raygun for CFML in the version you want, and then you have multiple ways of integrating it. If you want to go down the manual path, you basically create like a Raygun client, set up your API key, and then in some sort of an error handler here, for example, if you have a CF-catch struct available, you just send it to the Raygun system, and it ends up in the analytics on their end. If you use something like Wirebox for dependency injection, set up a singleton, basically, map it against a name, and then off you go, and you can just use that. So different ways of doing that. And what you end up with in these crash reports is they pop up in a web UI usually, and you get a summary that says, hey, something occurred there. There's a class name expression. There's a message like invalid call of the function, blah, 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 blah. And you get like a data object. And that data object can contain a lot of different things, among them a stack trace, because stack traces are obviously useful. So you look at the stack trace and you can see, oh, this happens in like com.something. This is actually an Android app, I think. So that happens in some UI class where a division by 0 was occurring. It can give you information about the client or the server, depending on what kind of integration you run. So if you, for example, have an Android app, you would usually try to collect stuff like, what phone was that where that error occurred? What Android version are they running, or iOS version are they running? How much memory is left? You know, like, what is the orientation of the screen, portrait or landscape, right? Because that can sometimes, even that can trigger an error, like you rotate your phone, stuff like that. So that's the typical client information bit. And for the server platform, you can get a similar thing, right? Like you can say, okay, I have maybe a cluster of 700 servers. On which one was it happening at the time, and how much memory was available, for example, or what was the CPU load at the time? And then you get like dashboards where you can filter by certain things, by your version of your application or your backend, or by which server it happened on, etc., etc. And what these bars at the bottom are, in this case, they are basically deployment trackers. So you can send your deployments to these crash reporting services as well, so that you can say, okay, I deployed the new version of my app on this day, and there's a marker for that. And now, like 5 minutes later, I've got this massive spike there. So maybe, just maybe, there's something related there, potentially, right? And that works nicely for backend and front-end apps, from my point of view. All right, so that's one example of a crash reporting service. And again, use whatever makes you happy and whatever fulfills your requirements. But it would be good to use something, I think. The next step from going from crash reporting or log collation is usually a thing called APM, Application Performance Management. And a lot of technology stacks have like very encompassing solutions for that. In CFML land, I almost feel there is no full all-in-one solution for CFML. And that might be changing over time, but currently the common approach that a lot of people, and also me, are using is to use Fusion Reactor for backend performance management. So you look at your server or your servers or your instances, and you look at the graphs and the CPU load and the requests, and you can do certain amounts of alerting in there as well. Then people use stuff like Raygun or Sentry or Firebase from Google if you have an app for structured crash reporting on top, and also for front-end performance management. And particularly the front-end performance management is interesting. I don't really know super many things about the JavaScript side of that, but for native apps, that is really an important thing, right? Because in native apps on devices, you have sometimes screens that behave really poorly because like the app has to be redrawn basically on a technical level a lot. And you might have a screen where the CPU on your phone, with you not even noticing, goes up to 80%. And how that basically manifests is that users are complaining like, hey, when I run your app, my battery drops from like 100 to 60% in like 7 minutes. And then you think like, okay, maybe something is churning a lot of CPU in the app, and that is causing a bad experience for my users on their devices. Or you get messages like, oh, my phone gets so hot when I use your app. And that should make you think like, okay, there's something going on there, right? And like front-end performance management is really important from that point of view. And then the third component of kind of a typical APM solution is stuff like Grafana or Logstash for logging and log shipping and managing log files, right? And to be honest, like when you look at like Fusion Reactor, for example, in the cloud version and the new stuff they've been doing now and they're showing here, probably some of these elements can now at least be partly done by Fusion Reactor as well. So you might see like, that Fusion Reactor is becoming more of a complete APM solution from how I see it. But currently, it's a big part of an overall platform, consisting of multiple components, for me at least. The other thing that is kind of interesting to look at is Logbox in this whole context of crash reporting and logging. So it's a logging framework, right? And like a lot of people think because it's box, has to be used with CodeBox. And that's actually not the case. It's a really nice way of standardizing logging from CFML applications, not just into files, and even though lots of people would use it for that, but into a variety of places, right? You can have logbox appenders that basically allow you to log into other things, and that might not be a flat line in a file, that might be a structured data set. It is part of CodeBox already, so it comes built in if you use the framework, but you can use it in pretty much any CFML application if you choose to do so. And again, I said like the idea is you have appenders that can, where you can structure your data and send it to different places where you need it to be. So Raygun for CFML, specifically, there is a new version, like I said, nearly done. That is pretty much a Lucy implementation. And that's mainly because, personally, I hardly ever use Adobe ColdFusion anymore. So at some point when this is out, hopefully someone contributes Adobe CFML fixes for that. It's a complete rewrite in modern CFML. It's a ColdBox module by default now. And it has its own logbox appender so that it can integrate with that logbox ecosystem quite nicely. There's also a thing called CFScribe that came out last year around August, September, if I remember correctly. And what that does, it's a logbox extension that allows you to route logs in a more flexible and more advanced way, basically, where you can have like, rules for where certain things should go, should they arise. Like, hey, if this error happens, I want it to be logged here or there, or maybe nowhere else at all. Maybe we just want to swallow it because it's not important. Right. So that's kind of a cool extension as well. And with that, I'll leave you with one last XKCD, again, about error handling. So we have a bug, right? It just happens sometimes. And the question is like, is it one of those bugs that are really bad? Maybe, or maybe not. And it happens that sometimes, unfortunately, even with the best crash reporting and error handling and logging, you still occasionally run into issues where you just want to burn down your system. Using the techniques I've showed over the last 40 minutes will help you to hopefully minimize these instances, but occasionally, sometimes you just need to get the lighter fluid and set it all on fire. And with that, here are my contact details in various places. Thanks a lot for coming and listening. Hope you got something out of it. Are there any questions people want to ask? Sure, Ben.
One thing that we struggle with at work is whether or not we want to log all errors that get thrown, or if there are like expected errors that we could safely ignore. We kind of go back and forth on that. Do you log everything that goes wrong, or are there cases where you don't really care?
Okay, so Ben's question was like, one common question at work is like, what do you log, right? Do you log everything, even expected exceptions, or just, let's say worst case, bad things, totally bad things? So my answer to that would be it depends, unfortunately. So I know that doesn't help you at all, right? Fine. It depends on the general level of errors you have, I think. So sometimes there are scenarios where you have systems that are generally very stable, and let's say you get a few hundred things that go weird per day or per week or whatever, you might as well log everything, right? If you have millions of errors and problems, depends on how much data you want to collect, right? I mean, if a system is that bad that you have literally millions of errors per day, I would probably focus really quickly on like fixing the top 10 of these in some way. And I've seen that in the past with clients, unfortunately, where like the situation was actually really dire, and you just say, okay, we need to stop the bleeding here, right? Because we don't even need to talk about crash reporting and like monitoring things over the long term. Let's just fix all these really obvious problems, essentially. I tend to lean towards logging as much as I can in general, if it's reasonable, and then ignoring alerts for it in my crash reporting system. So, I mean, in Raygun, for example, I'm pretty sure in Sentry as well, you can set up, obviously, alerting rules, but you can also generally ignore things, right? So, for example, one of my clients uses a translation service that regularly, at like, whatever, 5:30 p.m. their time, has a spike of errors because the company that provides that that translation service is doing some server maintenance that causes errors. I mean, it shouldn't, because they should just like fix whatever it's weird anyway. So these are expected, right? I mean, I know they happen, and I know there's a spike of a few hundred for a few minutes in that time frame. So I just put them to ignore, essentially. And if you have a good system, you can even ignore things based on time. You could say, like, between 5 and 6, just ignore everything that fits into this box of blah, 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 translation, throwing an error, or something like that. So, I mean, that would be my approach, essentially. I know, it depends. Yeah. I mean, the important thing is, if you log everything, or even if you log a lot, you need to find a way to deal with it. It doesn't help you if you just log it and then never look at it in some way, right? And that can be a problem with data overload as well, if you have these millions of errors, and then everyone is too busy or too overwhelmed to look at them in the first place. So, yeah. Cool. Any more questions? Nope. If you can think of anything, catch me afterwards, and I'm happy to have a chat and show you more about different strategies and different approaches.